Is it?
Sublimation. Yeah.
Is it? I'm being confident, guys.
This is sublimation. What about solid to liquid?
Condensation.
Melting.
Yes. So like when an ice cube goes from water, goes to water. You call that? Someone already said
Is it condensation? Is that right?
it. No, because what is the root word of condensation? Is condense. It's condensing into something more structured.
Isn't that liquid to gas? Or whatever, oh, that's evaporation.
If it's condensing, that means it's getting more dense.
Uh-huh.
So
It's going from gas to solid?
Down here.
Okay.
Down this side.
Got it.
So what would that be?
Condensation, gas to liquid. Yeah.
Okay, so what about solid to liquid? We already said it. Someone said it. Liquid to gas?
Evaporation.
Vaporization. Liquid to solid? Freezing. And then gas to solid. It's not very common.
Deposition.
Yes.
What was it?
Deposition. I wrote it down. Deposition.
Is it really? Oh, okay.
So just keep that in mind. What is this? This is familiar. Phase diagram. So just tell me real quick, what are each of the sections here?
Solid, liquid, and gas.
Is gas the top one?
Which one? Tell me.
The top one is gas, maybe?
This one?
No.
So, okay, if you have a really high temperature, what would that usually be? What kind of days would that be? Hi, for chemistry.
Yeah, am I allowed to say I'm sorry I'm late?
No, you're good. It's fine. There's a sign-in sheet. I don't know who has it, but just sign your name.
Oh, so gas would be the bottom?
Yeah. So just think, if you have a really, really high temperature, then that would only make sense to put gas. So what about these two?
That'd be solid and
Solid and liquid.
Solid and liquid. Okay, what is this point?
triple point?
Why is it called the triple point?
Because it is where all three phases of matter can exist simultaneously.
Yeah, it's like that weird thing where none of them have transitioned yet. What about, like, up here in this region?
That's as good a guess, I don't know.
No?
Plasma?
Plasma?
Super fluid?
Super. It has, yeah, say it again?
Super fluid? Or plasma?
There's super what?
Are you talking about
Superficial
where-
point?
It's really, it rhymes. Maybe you read it in it.
I always get these wrong.
Super saturated?
Let's see, it would be high temperature, but also,
High temperature and pressure? It's not plasma?
I'm not sure what plasma is.
I don't know, like in a star?
Probably not.
Really, really high
No, I
temperature.
know what you're trying to say. It is plasma, but it's
That's
not.
really high
Yeah.
temperature.
can this be multiple choice?
It would be critical, the critical region. You said official, superficial. And then the point here is the critical point.
So it's called critical point, not superficial, that I thought it would be. Oh.
Maybe it's super critical that you're in.
I don't know.
But it's critical, that's the word that
Got
I'm
it.
looking for.
Okay.
Okay, and then another diagram. What is this called?
Is that a 9?
It's a Q.
Oh, it's a Q, my bad.
Q
Okay,
for heat.
got it, okay.
Q for heat,
Yeah.
so is the T temperature? What is
Yeah.
It's the
Oh,
points.
is that the change in energy between the change in phase?
Mhm. So it would be called a, if it has to do with heat,
And
Heat diagram.
there you go.
Heat graph.
The heating curve, even though it's not a curve. I
okay.
don't know. So these, you guys went over this in class, right? This question? Maybe like really briefly. If they have a question on it, it'll be like, what's the transition between solid and liquid, or something like that, or calculate the heat exchange between solid and gas. So would this be the solid line or this the solid line? If you're going from solid to gas, as temperature goes up.
Solid would be all the way up until that point of increase again.
So this line here.
Right, and then at the flat point, that's where it starts melting.
Okay. So this is solid, liquid, gas. Why is the temperature constant here, even though you're adding more heat? Why isn't it? Why is the phase not changing?
The energy is being used to break apart the molecules.
Someone want to say that in their own words other than Wesley? Okay.
Well, I'm a little confused by the graph. So we have temperature on the side and then heat.
Yeah, so like as you
Temperature
add
not-
heat, the temperature will increase or decrease. So heat isn't synonymous with temperature. So like this is why I'm asking here, as you're adding more heat, why isn't the temperature increasing?
The temperature of. Okay.
Yeah, so you're starting with a solid, and then you heat it up, and the temperature's still not increasing, and then there's a point when it turns into liquid. What is happening?
The temperature of the solid is not increasing.
Right here.
Okay. What was the question?
Why is this here, like why is this not, the temperature not changing as you're adding heat? This seems counterintuitive. What is really happening? So like,
There.
say,
Well, doesn't each, I don't know, chemical or whatever we're trying to change have a heat capacity before it transfers into the next phase?
so like
Has
you
to
have
reach that
a,
level?
right, so what do you see in a beaker? Say you have like a liquid and you're heating it up and the temperature's not changing but it's not a gas yet. So it's like here. What is in the beaker? Is it still liquid? Still gas?
Yes.
Yeah, it's still liquid, but it's in the process
It
of
has like
becoming.
bubbles and stuff.
Yeah,
So it's like kind of a liquid,
Right.
not yet a gas.
Transitioning.
It's transitioning. So it would be boiling here. It would be melting. And then, like here is where you would, if they asked you, I don't know if they did, but if they asked you the heat, what the heat would be, or the heat change, or so this is a specific heat we're talking about.
MC delta T.
Yeah, and that would be for these here.
Is C a constant?
Yeah,
Okay,
and they would give it to you.
okay.
FUS for fusion, FUS and heat back vaporization. That's just terminology and stuff that you need to know when you do these problems. Okay. So I'm gonna have to write these questions on the board, but I couldn't print it. It's very inconvenient. How about we do this, because we have a lot of boards. I'm gonna give you guys a problem, and you write it down, and then you work in groups and solve it. And then I'll come around and, see how you're doing.